Now that the information revolution is here to stay, another revolution is standing in wait at the door.
Everybody's interested in genetic engineering now.
CRISPR is a technology that enables us to totally rewrite the genetic material of plants, humans and animals.
With all these DNA technologies that allow to do precise gene surgery on our DNA, surely this is another era.
All you need to know about doing your CRISPR experiment.
Soon, cells will be precisely programmed.
Viruses can be reprogrammed. They're essentially software. Think of them as apps for your cell phone.
And coding with DNA will no longer be just for expensive laboratories, but also for home use.
Come check out where CRISPR kits are being made.
Printing medicines and changing your own genetics? Will this soon be possible?
My particular application is to write software that kills cancer cells.
We get tattoos and stuff like that. Why can't we, grow a tail or grow wings?
It loads a lot of responsibilities on the shoulders of everyone.
And I tell you, it gives me goosebumps because I know that a 20-year-old student at a university that is learning biotech today has all the power and technology at their fingertips from their dorm room as a major pharmaceutical company. That's a game changer.
This is Backlight. Welcome to the world of your programmable body. Slowly, we are beginning to control DNA, the genetic code of life. DNA is comprised of 4 substances designated by the letters A, C, T, and G. The sequence of these substances determines the genetic code of a cell. With CRISPR, we can now accurately read and write with these 4 substances, and thus reprogram the cell. But this is still not enough, according to Hessel.
In terms of programming, we're still down working with the bits. In biology, it's A's, T's, G's, and C's. In computing, it's ones and zeros. We're working at the bit level most of the time to assemble the code. That is extremely hard. But what we've been seeing over the last 10 or 15 years as synthetic biology, the field has come into play, is we've started to modularize the instructions. We're saying this little bit of A's, T's, G's, and C's is a switch to turn a gene on. So now we just call it a switch, and then we build another system that is, a reporter. And here, so we start to functionalize these code blocks, and now those code blocks have the genetic code encapsulated in them. You never have to look at them. And once you've done that, now you can start to assemble those code blocks and say, here's a switch, here's a sensor, here's a reporting device, and you just drag and drop the components to build a new circuit. So now it becomes accessible to someone who isn't a biologist. Now someone that is familiar with even wiring a simple electrical circuit can now build a simple biological circuit. And that's why we're starting to see kids, literally 7, 8 years old, starting to build their first biological constructs.
Josiah Zayner may no longer be a kid, though he may sometimes behave like one. But he is a real biohacker. He sells CRISPR kits on the internet to anyone who wants one. He once worked for NASA, but found it too bureaucratic. His living room has now been transformed into a packing division for biomedical items.
Hey everybody, we're here at the Odin in West Oakland, California. Come check out where CRISPR kits are being made. Over here, starting and left back, we have Alan making the media. Micah.
How's it doing?
Peter. And this is the kits we make and we ship out to people. So our kits come with everything people need to do CRISPR experiments. You don't need anything, no experience at all. So I grew up in like the late 90s when there was like this whole computer hacker type culture, right? Where it was like, you learn how to do some cool stuff and then manipulate technology to get it to do what you want to do. Well, I saw that like biology is this interesting technology and maybe different aspects of biology can be kind of hacked. this idea of like a biohacker as opposed to, say, a computer hacker started to be born in my mind. And I started to try to develop ideas and experiments along this line. And I thought, well, maybe I could make a kit and get that in the hands of people to show them how to use this technology. And then people, you know, got really excited by CRISPR. I think the coolest thing about CRISPR is not necessarily like all the genes it can edit and all the things like this. It's that like everybody's interested in genetic engineering now, right? Even people who are like anti-GMO or like didn't like GMOs, now those people are interested in genetic engineering because of CRISPR.
Zena experimented with CRISPR on himself. He attempted to make his muscles grow more quickly. The attempt failed, but his enthusiasm only grew.
My dream is that it becomes like more open, people become more open to human beings changing their own genetics as adults or as children, change the way we think about being human. Instead of just everybody being born with the genetics they have for their whole life, maybe we can start changing that up. And for interesting and fun stuff, you know, everything doesn't have to be, everybody, you know, cure this disease, cure that disease, you know? It's like, you know, we get tattoos and stuff like that. Why can't we, you know, grow a tail or grow wings or, you know how much scientific research has gone into like growing a tail in human beings? Probably like none. But like a lot of people probably think that's pretty cool. Companies can do that if this technology opens up. Or like growing wings. Who knows if that's even possible? Probably not. But nobody's trying, right? Or like different things, you know? Changing your hair color or skin color, growing more hair or less hair, or, you know, there's so many opportunities for this technology to be more than just, you know, another medical treatment or another, you know, technology that only big pharmaceutical companies own. We think that genetic engineering is such a powerful technology that it should be accessible to everybody. So, in effect, nobody owns CRISPR and everybody does, right? It's kind of like, you know, any sort of knowledge. Like, it's like saying who owns knowledge. I mean, some of the academic publishers might say they do and charge you $100 to read a scientific paper, right? But, in effect, you know, knowledge isn't owned.
Zena and Hessel both have the same goal, making biotechnology accessible to everyone. Zena does this with his CRISPR kits, and Andrew Hessel through making biology digital.
My whole goal was to bring the tools of biology into the digital world, digitize them as much as possible, make them automate, make them accessible via computing, and put an open source business foundation around it so that we can share information and ultimately build a community that can work like the pharma companies.
With digitizing biology, Hessel means creating on the computer viruses containing DNA which could then be utilized, for instance, to help fight cancer.
Viruses are really interesting biological agents. I do not consider them to be alive. I consider them to be software. And you can, if you buy a software program, it is not alive unless you load it on, it does not operate unless you load it onto a computer. So a virus by itself is a bit of protein and a bit of nucleic acid, either RNA or DNA, that you can think of as almost like a floppy disk if you're my age, or a memory stick today if you're modern. It is a program loaded into a physical structure. That physical structure will dock with a cell and load the program into the cell. And now most of the time the program is make more viruses. But we've gotten very good at engineering viruses to deliver programs that we think are interesting into the cell. Either make this protein because it's a good drug, or we can load a program into a cancer cell that says die. So viruses can be reprogrammed. They're essentially software. Think of them as apps for your cell phone. But we have this opportunity now to start to design viruses from scratch. It is a way of making programs for biology that can then do useful things. So the virus is simply the way to load software into cells and add new applications. We already get personalized trainers, personalized diet, you can get personalized clothing. I believe more and more of our medicines and medicines that keep us healthy, think of them as vitamins, should be personalized as well. And eventually I can see having an EpiPen type device that has essentially a pharmaceutical company inside the device. And the doctor can upload your medicine into that device, and it just goes beep when it's ready, and you do an auto-inject. So that's the future. How long it takes to get there, really depends on our will. But there is nothing science fiction in that process today. We're already seeing the miniaturization of all this equipment. The design tools already exist in the cloud, and ultimately single-use injectables are used all the time with things like EpiPens.
Hessel suggests that for around $100, you'll be able to get a kind of medical Netflix subscription to keep your DNA healthy. These are now only ideas, and Hessel's company is just getting started. But fiddling with our DNA is already becoming commonplace. Reading your own DNA, DNA analysis, designing and printing DNA codes, copy and pasting DNA using CRISPR. It's all becoming cheaper, more accurate, and easy as child's play.
And we got the bacteria in these little vials. They're hard to see because they're bacteria,
What kind of bacteria?
Really tiny.
What kind is it?
These are special strains of just lab E. coli, non-harmful, non-hazardous, non-pathogenic. They can't cause disease or anything.
And the DNA, where does it come from?
We actually get it synthesized from companies, and then put it in these little tubes. So you can see it frozen in there. Frozen DNA. So a lot of these things are very science specific and really expensive if you actually bought them, from normal companies. So we got, this holds tubes. We got pipettes. So pipettes are basically devices that allow you to move around small amounts of liquid. They suck up and move around liquid. Every scientist needs one. We got tips for that. You need chemicals to help get the DNA inside the organism. And then we need the DNA, put these in the kit, the guide. All you need to know about doing your CRISPR experiment.
And where is it going?
This one is going to the Waag in the Netherlands.
Experimenting with DNA in a backroom or garage. It's reminiscent of developments in the 80s when Bill Gates and Steve Jobs were playing around with computers. But playing with DNA is different from playing with computers. The CRISPR technology has travelled widely during recent years. Experiments with gene alteration are now going on a global scale, and experiments with the genes of embryos.